here. So this is a single program done in object-oriented programming in C++. Here's our class. We have parameters. Parameters are what it's called when you're creating the signature of something, like a function. Everything is called a function in most places I've read. In C++, other languages differentiate between functions, and methods are what are used in object-oriented programming. So I tend to say method in here too. So when you call this function or method, the parameters need to be passed in from where we're calling it, which is right down here. So at this point, they're called arguments. Arguments meaning they can change and they can be different. The values of these two variables, which I think we hard-coded that, are copied to these variable spaces. So the information from the memory address that's stored in the memory address of the other place is copied to these two new variables. These are not the same ones as we had before. These are the ones coming in. So these are coming in from the outside world. We also have internal storage of, where am I? There we are. We have internal storage of width, length, and area, and putting M in front of it is like a convention for C++ programming to indicate that this is a member variable, meaning it belongs to the object. Another way to say that it belongs to the object is to use the this pointer. Do you have to use both of them? No. I'm not sure why I use both of them, except to show that there is another way to do that. I like the M width because then it's easy to see right here. M width, width, length, M length. You do not have to use both. I think that doing this is more confusing because as you see this, when you get further along, you have to put a this everywhere, but that's just a preference. That's not a rule or anything like that. All right, so we get this in here. Now, this is stored internally inside our object. As part of the properties, as part of what the object contains, because this is the class that creates the object. This is the signature of the constructor. The signature of any method or function is this. What's the name of it? What can we do? The signature of this one is this. This one is okay, we get information out of it. We return something. That's what the signature tells us. We're returning some information, which in this case is the result of a calculation. And in this case, this is also the result of a calculation, but we're returning something. We do the calculation, then we return the M error. I don't know why I didn't do a perimeter too. Okay, I should have, shouldn't I? So far, so good. This is how you have the program stopped if you decide to double click on it, because these are executable programs. If you decide you want to go, oh, well, let's see if this thing works, you can double click on it. It will stay open. That's the only reason that's in there. If you run it from the command line, it'll come right back to the command prompt. One of my students liked to double click on this several years ago, and I said, well, here's what you add, and then you can double click to see if it'll run. So far, so good. And it's not like C++ isn't obvious, but it is obvious. And it's cleaner, I think, than what we do in Java. Java has way more curly braces and things going on. And Python doesn't have quite this type of setup because it does not enforce public. It does not enforce private. C++ and languages that are not scripting languages enforce private and public. JavaScript, TypeScript, Python, anything that's a scripting language does not enforce private and public. That's part of data encapsulation. So you can keep people away from directly manipulating this. They can only manipulate it through the methods. That's the only way they can do anything. All right. Questions, comments? Oh, well, good to know. So to break it out into 3 files, this is saying, this is like called a header guard. Oh, I didn't put that in there, did I? I should put that in there. It's called a header guard. So what this is for is this file is not used directly. This file uses it. So if we include this rectangle H what the header guard does is prevents it from, if we accidentally do this, it won't import it more than once. The first time it'll be imported, the second time it'll say, oh, we've already got that, we're done. That's what a header guard is for. And it is a convention to put in a header guard. I don't know if it's actually enforced or not. I've never tried it. So this is the header guard. If there's already a definition of rectangle H, we jump out. If there isn't, so this is an if statement, we now define rectangle H. We're defining the class. Right? We're defining what are our constructors, what are our methods, what are our private data members. So this doesn't do anything. This is like the outline of our class. The end if means, okay, at the end of this, this is what's being defined. We start the definition, we'll get down to here. This is the end of our if statement. This is what gets included. So far, so good. So this is defining all the prototypes. Now the actual implementation is here. So we include this. And then this shows, okay, this is what actually happens inside that rectangle business. Just like we've shown before. We multiply, we divide, we subtract, we do all that stuff. This is, you can think of this as kind of what's being exposed to the program. This is the public stuff. This is all the internal things. Might be a way to think about it. So far, so good. So it takes 2 files to build a house with C++. So far, so good. So we're going to end up with 3 files, count them 3. Because we need a main. Oh, you can't open an executable directly. There we go. So what do we include here? Well, rectangle CPP includes rectangle H, right? And here we're including rectangle H, which apparently brings this along at the same time. Because when you compile it, this compiles with this, and then this compiles with whatever this came up with. I think that's how it works. Here's our program. So this part of the program, I was talking to one of my students the other day about this. You may have heard the term full stack development. Full stack development, yeah, that's what, remember we had Will came in and did his little stuff about all what he does. So full stack development is sometimes, this is one of the paradigms of full stack development. MVC, Model View Controller. We worked with this last semester with SQL. And as we go, we're going to work on this more and more with all of our programs. So the model is the data or the database. The controller is all the logic, calculations. I always call it business logic because it's what is doing the thinking. All we're doing here is providing a view for the user. This is where the user interacts. There may be more layers in a stack. These are 3 of the big divisions of a stack. So are we doing that with our program? Well, yes, we are. Right, we're creating, this is our, well, actually we're not. We're doing our view and our stuff all at the same time, aren't we? But anyway, this is our data. And we kind of mix up things with the business logic a little bit. Let's see how we're using the rectangle one to get information. All our calculations are going on inside that. So we're misspelling perimeter. Oh boy, there, perimeter. What we're doing is when you split things up into like model view controller, you're doing what's called abstracting. Meaning what's basically going on in here is anything in here have anything to do with calculations. Does anything in here have to do with data manipulation or anything? Yeah. Is anything being stored in here? No, we have input. We're creating an object. We're manipulating the object. We're showing things to the user. That's it. Boy, I had a spelling day with this one, didn't I? All of that is taken care of back here in our back end. So as your programs get longer, even if they're shorter and you think it's going to get longer, at some point, we're going to want to split it out into pieces, which we have been doing as we've gone. I've just never said that this is one of the first steps to what's called full stack development. It's usually referred to because so much development is done for the web now. Usually you use web frameworks to do this sort of thing. But if it's a GUI program, it's going to be divided up the same way, just like we did with our SQLite programs that we did. Make sense? I see a nodding head. Andy's deep in thought. Jessica's being Jessica. Okay, she's nodding her head. All right, so the next thing we're going to do, and this is different, and oh, I keep forgetting about Ansonia and our Mac.
Yeah.
Because I don't use a Mac and I don't know how Macs work, but I should do this in Linux and then I'd be able to tell you. So in Windows, we use batch files. In Linux, you use script files. It's basically the same thing, except you're going to have compile.sh, which just stands for script file. But it's going to be basically the same thing. You can type it in every single time how you want to compile something, or you can put it in a script file and it does it for you. So G++ activates our compiler. Dash wall is optional. That is just saying if there's any warning, please display any of them. We have to list all of our files that are part of the compilation because we have more than one. -O means this is our output. Pause allows the file to stop so you can see if it worked. So how do you know if it worked? In this case, no feedback is good feedback. It worked. I had a student confused on that. They were thinking that something should show up, and I said, no, when it works, this is what you get. It all worked fine. So there's my new file compiled on whatever today is, 213. And I double click on it or run it at the command line. There we go. So I can also do the same thing at the command line, but I have put all of my little files in here. So in Sonia, where it says compile.bat, you could say compile.sh. That's just a common extension for a scripting file in Linux. And I know Mike will correct me if I'm incorrect. Extensions don't matter for Macs and Linux, but it's just a convention so you know what it is with just glancing at it. It's like CPP and H and all that sort of thing. And Windows is .exe, and Linux and Mac, you don't typically have extensions because they don't care about extensions. It's just the name of a file. Linux and Macs look at what's in the file. What is the contents? Is it binary? Is it Word? Is it whatever? So Linux and Mac look more deeply into the actual content. Where Windows relies on what are these little extension pieces added onto the end. And at the end, we have our program that works. Now I could have done this whole thing at the command prompt too, which is a good idea. dir, ls and Linux. So I can run my compile from here. And I can run my program from here, which would be rectangle, tab complete. Tab complete is your friend. There. There's no reason to avoid the command line. It makes you look like you're hacking into the Pentagon. Right? Can anybody tell, a normal person tell that I'm just typing in gibberish? Actually, there's a screensaver. There's a screensaver or something somewhere that simulates all that stuff, and all you have to do is type. I think it was Mike that came up with that. There's like a Linux program, isn't there?